The red giant has become a white dwarf.
By the time a star reaches the white dwarf stage, the fusion process has stopped. The engine has finally come to rest.
Our sun will end its life as a white dwarf, no larger than the Earth, but 1,000,000 times denser.
A white dwarf is a pretty amazing object. It's incredibly dense. If you could take a sugar cube-sized chunk of white dwarf and put it on the surface of the Earth, it would be so dense it would fall right through the ground.
At the heart of a white dwarf, astronomers believe there's a giant crystal of pure carbon. A cosmic diamond, thousands of miles across.
The idea that the sun will become this sort of cool, dark lump of cinder material is kind of sad. But that really will be sort of a trillion carat diamond. Think of that, a diamond in the sky.
But stars can create something much more precious than a massive diamond. When stars much bigger than our sun die, their death is much more violent. But in dying, they create the building blocks of life. Giant stars live fast, burn bright, and die hard. But from their destruction comes life. The death of massive stars creates the building blocks of the universe, the seeds of life itself. Less than 600 light years from Earth, the monster star Betelgeuse is near death. Well, in space years. It's younger than our sun, millions, not billions of years old. But the fusion at its core is far more intense.
Betelgeuse is a different beast from the sun entirely. It's a red supergiant. And the reason is because Betelgeuse is more massive. It has 20 times the mass of the sun. And that means what's going on in its core is very different than what's going on in the sun's.
Massive stars generate pressures and temperatures greater than anywhere else in the universe. The gravity of Betelgeuse is so powerful, it can smash together bigger and bigger atoms. The core of a massive star is a kind of factory, manufacturing heavier and heavier elements, which is what also leads to the star's destruction. Once it makes the element iron, the star is doomed.
In the world of science fiction, there are many ideas about what a star-killer machine might be like. Strangely enough, it's as run-of-the-mill as something as iron.
To a star, iron is the most dangerous element in the universe. It's poison.
Iron absorbs energy. From the moment a massive star creates iron, it has only seconds to live.
The star is trying to dump energy into that iron ball and trying to make it fuse, but it can't. And so that ball is robbing the star of energy, and it's that energy that is supporting the star itself. So as soon as that iron starts to be created in the core, the star has written its own death sentence.
The battle between gravity, trying to crush the star, and fusion, trying to blow it apart, is over. With iron, fusion hits a dead end. Gravity always wins.
The iron core collapses. The outer layers of the star slam down into it, and a huge explosion is generated. Is the single most violent event in the universe, a supernova.
In just a few seconds, supernovas create more energy than our sun ever will.
Within a couple seconds after beginning to make iron, the star explodes in a supernova. So think about that when you're holding one of your iron frying pans. The iron killed a star in just a few seconds. Dangerous stuff.
Telescopes around the world